Hello student, let's see the problem student. What is the problem? Describe the trends in the atomic size of the first series of the transition element student. What is the atomic size of the first series of transition metal? Okay. So first series of the transition metal, what are they student? That is we are having the scandium, then we are having titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These many are there student, and that we have to understand that how they vary student, right? So here we are going to understand. Here you see student, atomic radii of the first transition series decreases from scandium to chromium student. From scandium to chromium you see student, it is keep on decreasing. Scandium to chromium you see it's keep on decreasing, right? Now see student what is happening, then remains almost constant till the nickel, and then increases from copper to zinc. So it is going to be little bit student, it is the going to be constant here from the chromium. Here you see these are the quite constant student, 1.25, 1.26, 1.25. Okay, they are the quite constant student. Now see here, the region of these variation in the atomic radii has been attributed to increase in nuclear charge in the beginning of the series, but as the electron continue to field in d orbital, they screen the outer 4s electron from the influence of a nuclear charge. When the increased nuclear charge and increased screening effect balance each other, the middle transition elements, the atomic radii becomes almost equal. So what are there student? If you see here the nucleus, what are there? Here the electron are being filled in the 3d orbital. Suppose this is the 3d orbital and here is 4s orbital. So what is happening? The nuclear charge is getting, positive charge is getting increased. This is increasing. But here the number of electron also increasing in the orbital. So what is happening? They are screening here. When they are screening the 4s electron, so what is happening? Size become the constant. The effective nuclear charge become the constant. It is not going to influence more. That is why the atomic radii almost constant Mn to Fe towards the end of the series. The repulsive interaction between the electrons in the orbital become very dominant. As a result, there is an expansion of the electron cloud. Consequently, the atomic size increases. Now in the here you see copper and zinc, nickel, copper, zinc, it is keep on increasing. The reason behind this increase, student, reason behind this increase, what we can write student, because the 3d orbitals are completely filled. So now there will be the interelectronic repulsion. You see, the towards the end of series, the repulsive interaction between electron in orbital become very dominant. Repulsion because of the pairing of electron. As a result, there is expansion of the electron cloud. Consequently, the atomic size increases. So this is all about the variation. You see, student, the data's 1.66, 1.47, 1.34, 1.25 decreases. Here also Mn also decreases 1.25, but after that 1.26. They are constant. 1.25 constant. 1.45 constant here, little bit maybe something, 1.28 little bit here increase. So these trends you can understand, here decreasing because increase in the nuclear charge, here constant because of the balancing of the increase in nuclear charge and increase in shielding effect, so that this here constant, here increase because of the repulsive forces. So this is all about the answer. Thank you very much for watching, students.